Guys, today's video is on graphing systems of linear inequalities. We did graphing regular linear inequalities prior to this with the shading and the dotted lines or the solid lines, but here we're going to do multiple lines with two different or even three different colors, and what we're going to do is find the shading overlap where the colors overlap. Let's start with number one and graph these two lines. So number one, in blue, the y-intercept's -1, and make sure that your equations are in slope-intercept form prior to graphing them. In number one, they both are. So the slope is down 2 over 3, down 2 over 3. Also go up 2 over 3, and I strongly recommend that you keep making the dots throughout the graph, and it is a solid line. Do the best I can to make that. It's solid because of the equal to, and we're going to shade below because of the less than sign. The other graph starts at -8 on the y-axis all the way down here. It's an up 1 over 2 slope, and it is also solid. But for this line, we are shading above. And now for the solution, you have to identify where we had blue and red. And I'm going to put that in to purple right here. So you can do a third color if you want, or you could just circle the area and identify that's the solution. What that means is that anything in this purple region, including these solid lines, if you plugged in any of those ordered pairs here, you would satisfy both of these equations by plugging them in. Let's move on to another one. Number 6. The first equation is not in standard form, so let's solve for y. -5y is greater than -4x minus 5, dividing everything by -5 and flipping the sign. We get y to be less than +4/5 x plus 1. Let's graph this line, slope-intercept form of 1 up 4 over 5. And we go down 4 over 5. It's going to be a dotted line because it's not equal to. And you're shading lower because of the less than sign. Everything down here. And the other graph is x is less than -1. Since it starts with x, it is a vertical line at -1. That means it is dotted at -1, and less than is this way. I can see my overlapping region. I'm going to put that in green. It's right here. So there is my solution. Everything in green there, not including these lines because they are dotted. So everything in between them. Doing number 7 now, checking which ones are solutions. You could just set up and graph these two equations, but this problem could easily be solved by substituting in each of the ordered pairs and making sure they satisfy both inequalities. Let's just try the first one by substituting in 1 minus 6 times 1. Is that greater than -48? So is 1 minus 6 greater than -48? Is -5 greater than -48? Yes. So it worked for the first one. Let's check the second one. 2 times 1 minus oops, plus 3 times 1, is that less than 9? 2 plus 3, is that less than 9? That makes 5, which is less than 9, so that worked. So you would check the first one. I would practice trying to find if the rest are solutions to the inequalities as well. I'll leave that up to you as an exercise to finish up. Do a word problem, setting up the system of inequalities, graphing, and then finding the shaded region. So number 8, to raise money to attend a Boy Scout camp, Alec is selling popcorn. Small bags sell for $4 each, and large bags are $6 each. You need to earn at least 300. So we got 4 small bags plus $6 for a large bag. Has to be at least, which means greater than or equal to $300. That's the first equation. The second equation, he will also earn a badge if he sells at least, again, 60 total bags. So the number of small bags plus the number of large bags has to be at least 60. Let's graph these. First, we need to kind of set up our x and y axes. Let's make x be s and y be L. And after we solve for L in both, since L is now Y, we can kind of come up with our scale. Let's do the green one. So we'll get L to be greater than or equal to negative 2/3 S. And then I have to figure out 300 divided by 6. I believe that's 50. Okay, that's what L is. The first equation, also solving for L in the second. Again, L I'm making kind of like our Y value. L is greater than or equal to negative S plus 60. So looking at our y-intercepts are 50 and 60. So maybe we make each tick mark go up by tens and so on. And the S's, let's also make them go up by tens and see what happens. Okay. Green one. Y-intercept is 50, which is right here. And the slope is down 2 over 3. Since both scales are the same, we can just go over down 2 boxes over 3 boxes, and then down 2 boxes over 3 boxes. And since the scales are the same, it's going to be a solid line. And you don't include arrows here because we're not going to go into any other quadrant other than 1, since the amount of bags we can sell is only positive. And we're going to shade above, just like this. And then the other graph has a y-intercept of 60, and it's going down 1 over 1, down 1 over 1. Make sure I'm doing that right. It's also going to be a solid line, not drawing arrows. And then you're going to shade above. Which gives us a whole bunch of options here to have as our possible solution set. So everything basically coming around here, everything in here, that's the solution. And answering question B, give 2 possible combinations. Let's make it easy. Let's go 30, and then up here. So we can do 30 small. And what is that? 60 large. Or he can do, let's pick this dot over here. There's 90 small. And it looks like 20 large. Those are all possible solutions in our solution set. Let me know what questions you guys have. Again, these are all lines right now. We can even get to making quadratics with lines eventually. But let me know what questions you have just with this stuff, and have a great night.